There's been a lot of question about helical and offset and what way we should do it and why. Here we have about a 2 to 3% left offset straight fletch. Got a bare shaft. This is a right helical. So I wanted to switch to this a little bit smaller vein that actually has a little more surface than the longer one. And I wanted to shorten my arrow a little bit to see the results. So while I was doing it, I thought I would test all this stuff and see how it works. So we're going to shoot this bare shaft to determine which way the arrow's spinning. I got a dot on this shaft. Okay. I've loaded the dot straight up. So we're going to determine how far it takes to get it to spin. So the object is to see which way the arrow spins naturally without fletching first. So from about 1 yard away from the target, we see that the arrow spun just a little bit left. We can tell that by the knock rotation and the dot. 1, 2, just a little over 3 paces. Should give us about a quarter rotation. That is exactly a quarter rotation. Left. Now we're going to try the offset left. Let's see if it makes any difference. We're at the same marker. We can see it's down here. It did rotate a little bit further than the bare shaft. So, okay, so we have a little bit more than a quarter rotation now at about 3 paces, the same as we did with the bare shaft. So we can see that that is actually spinning just a little bit more than it was before. Now the question is, what if we fletch it the wrong way? So everybody just, let's try the right. So now we're going to go with not only a right offset, but a right helical. So this essentially should make it spin faster. So the question is does this start out spinning the wrong way and then have the fletch recover it? So is there a pause in there? It's going to take a few shots, but we'll show you. So we see here, and you can see by the knock, it's taken a slight turn to the left first at close range. And we're going to see how long it takes it to get to a quarter rotation right. 1, 2. So from 2 paces, let's see if we get rotation yet. And we can see by the knock positioning alone and the dot position, it's still wanting to go left. So we can see that the dot positioning on the arrow shaft was about the same between the two shots. So the first one was at 1 pace. The second one was at 2 paces. So we can definitely see that between the first shot and the second shot, there was a pause there. That arrow stayed the same for basically 3 feet. It didn't spin. Yeah, we're right at 3 paces again, a little bit over 3 paces. You can see by the dot there, it barely turned. So if you remember right, the first shot we took with the bare shaft was at about 3 feet from the target, 1 step away. We had about the same rotation as we do here, from 3 paces away, basically 9 feet, 10 feet away from the target. Okay, we're going to go, we're at 4 paces now. Okay, we're now looking straight underneath the arrow. So it's a half rotation now at 4 paces. So it's picked up the speed. Now we'll try the left offset at 4 paces. So we're looking straight up from underneath the arrows. That's a matching result at 4 paces, a half a turn. I think what we learned here today was that if you fletch an arrow with the opposite offset or helical as your arrow wants to naturally spin, that you'll cause it to pause. And it looked like it spun the wrong direction at first, and then it actually paused for about 3 feet, what it looked like to me, where it wasn't spinning at all, and then it started to rotate after that. So I think that could cause some troubles in broadhead flight myself, and grouping in general. Brought to you by BalancePointArchery.com.